Good morning all, it's Postbag, and it's Postbag number 50. Now of course 50 is only relevant if you celebrate decimal numbers, which I don't really, so perhaps I should have celebrated number 47 because that's kind of a resistor number, or maybe number 64 because that's a binary number. Anyway, on with the Postbag. Now this one I'm fairly certain is from Alice, and this is the one that came through the letterbox while I was actually filming my FPV video. Shall we have a little clip of that? Yeah, let's have a little clip of that. Oh, the postman's here. Ooh, what's this? Something from China, I think. Right, let's get this thing open and see what's inside. And it's a GPS module. So this is another quadcopter inspired purchase. Quadcopters using GPS for things like position hold and mission planning and that sort of thing. So this is a GPS V3 Neo. Now it's called a Neo because it takes the Neo format module here, this leadless chip carrier. And you can see that this is a Ublox product, a Neo-7M. Now the board here has little tick boxes for 6M, 7M and M8N. Okay, so what's the differences between all of those? Well, I'll have a look a bit later on. Now also on the board here is some sort of memory chip, which would be non-volatile. And that makes it a rather odd thing to have a battery there. So the memory must store one set of parameters and the battery must hold data somewhere else because these little flash EEPROMs don't need batteries. So this is very interesting and mysterious. Now the antenna is one of these strange square ceramic things with a bit of solder, it looks like, poking through a hole in the top. There's a tin can on the bottom. This is clearly a printed circuit board sandwiched between the two. So there's probably some electronics on there. Or is there? Maybe it's phantom powered because that's only a 2-wire antenna connector on one of these. I can't remember what that connector type is called again. Now this PCB has these 4 square pads. It looks like you could solder this unit down onto the back of the board, and that would be quite neat, although probably what I'll do is stick it with some double-sided tape. But that's quite a neat module. I guess this has to be facing up to face the satellites, but I can mount it with these 3mm holes and just have the electronics section upside down, mount that down on I don't know, a bit of chipboard or something. So yes, that's all interesting stuff. Now I'm going to come back to this after I've opened the next envelope because I really want to start exploring this thing. I have done some reading already, but let's go to the next Postbag item first. So this one is from Pig Chan. Now that's a really strange name. My wife is Chinese, she's from Hong Kong, and when she came over here to the UK in, well, she was 11 years old. She was asked to pick an English name, and she said she looked at a list and they were all gobbledygook. So she picked one randomly, but to pick the name Pig would be very odd. Anyway, let's open it up. So in here we have this stuff. It's an Arduino. In fact, it's 2 Arduinos. Let's get them out of the bag. Now, of course, I suppose I should call this an Arduino compatible microcontroller product. What's happened to my focus? So this is a DCC-Duino Uno. So it's a device compatible with the Arduino Uno. That looks like a CH340. Of course, there's the microcontroller. Oh, that crystal looks like it's been whacked a bit. I hope it still oscillates at 16 megahertz. We assume it will. They don't put many of these connectors on now, do they? The female connectors aren't on there. None of the male connectors, actually none of the male connectors are even supplied. There's an ICSP header connector there, but I'll have to use my own male connectors on the inner rows there. Male connectors here. But yeah, that's pretty much bare bones, isn't it? Now, what attracted me to this was that it's slightly deviating from the normal standard in that it's got a micro USB. I can't remember whether I've got an Uno with a micro USB. I ought to look, really. One thing's for sure, though, I don't have a Nano with a micro USB, and this is a Nano with a micro USB. And when I saw this, I thought, well, I just have to have it because it's just ever so slightly different from the, what's that? Why is that a 12 megahertz crystal? Oh, that's for the CH340. The CH340 there is on the back. Ah, yes, now you can see, let me get in a bit closer. There's a 12 megahertz crystal here, which is definitely for the CH340. In fact, you can even see the tracks running from it in underneath that chip. And then there's also a ceramic resonator there, 16 megahertz, we assume, for the 80 mega 328p microcontroller. So this is a really unusual layout. As I say, it's got the USB micro connector there. The pins, I think, are supplied. Yes, these pins are supplied with this one. ICSP header there. So it's really nothing very unusual. It's just a Nano with a micro USB connector. I just thought it was a bit interesting. Let's have a look at these two items on eBay. So here are those two items on eBay. The seller is Ichozi Love, and we've got the Uno with 80 mega 328p CH340 at $3.95, and the Nano V3, again it's an 80 mega 328p CH340, $2.65, total $6.60. So I've just gone into the listing for the Uno, and there's something new here. There's a what looks like item ratings. It looks like you can actually now review items as well as sellers. Not seen that before. I'm not sure how new that is. Anyway, here's the Uno, and it's, as I say, $3.95, free shipping. Now the seller, as I say, is Icho Say Love, of course, aka Pig Chan. And here's the micro USB version of the Nano V3. This one is $3.95. I didn't think that was $3.95. I thought that one was cheaper. That's interesting. I got this for $2.65, but the price now seems to be $3.95. I'm not sure why that's shot up in price. So I think another reason I bought the Pig Chan Nano is because it was $2.65. I've just searched for the Nano on Alice's store, and that's $3.89. So I think it was the price that attracted me as much as the micro USB connector rather than this mini USB connector. But the price doesn't seem to be $2.65 anymore. Okay. And of course the other item is the Ublox Neo-7M GPS module MWC APM 2.6. That's the Autopilot Mega. Replaces the Neo-6M. Does it replace the Neo-6M? I suppose it does, but it adds additional features. Anyway, that's free shipping. A seller you've bought from, yes, quite a few times. Alice 110 1983. So while I've got my camera still pointing at my computer screen, I thought I'd come to the Ublox website and the Standard Precision GNSS section. Now GNSS stands for Global Navigation Satellite System. And I want to track down a comparison between the different Neo modules. So this is the one I've got. It's the Neo-7, and this is a GNSS engine for GPS or QZSS. I'll have to look that one up. And GLONASS. Okay, it's backward compatible with Neo-6 and Neo-5 families. There's a 7N, which has the TCXO. Now that means it's a temperature-controlled crystal oscillator. So that is very, very high precision. That's going to be a bit more expensive. The cheap one, of course, is the 7M. That's the one that I've got, which just has a regular crystal. There's some product information. There's a Neo-7 product summary PDF. But there's also a GNSS module guide, a 4-page overview. Let's take a look at that. Now this document is essential reading, so I'm going to put a link to this PDF in the description. But here are all the different form factors. We've got the little miniature EVA, the Max series, the Neo, this is the one that's on the module that I've bought, the LEA, the CAM, and the PAM. Now let's go down a little bit further, and we've got information here on the form factors, the model number, the 7, the 8, and of course 6 and 5 and all previous models, and the letter at the end, which tells you whether it's crystal based or TCXO, which is the temperature controlled crystal. So we're starting to understand now what all the different modules are. So here's a comparison between the Ublox 7 and the Ublox M8. The 7 has a single RF section, the 8 has a dual RF. The 7 can do GPS or the QZSS, now that stands for Quasi-Zenith Satellite System, or GLONASS. Now GLONASS is the Russian GPS system, which has 24 satellites, as opposed to the American system, which has 32 satellites, I believe. And the M8 can do GPS or the Russian GLONASS system, or Baidu. Well, that sounds a bit Chinese, doesn't it? I'm pretty certain that from this we can understand that the 7 can do either GPS or GLONASS. You probably have to switch between them, whereas the 8 has concurrent GNSS, so that it can probably do two systems simultaneously. And by looking at two different GPS satellite systems, you can get a much more precise positional fix. Now here's some information on the Neo form factor. It's a versatile hardware connectivity. It actually has USB, UART, SPI and I2C. Let's have a look at the module itself. Now I don't have all that connectivity on this module. All I've got is VCC, RX, TX and ground. So it seems that I can only get to the UART part of this Neo-7. The USB, the SPI and the I2C must be used for something else. The I2C, I'm pretty certain, is used to talk to the little memory chip here, but I didn't realize this thing had USB, and I'm not sure what the SPI is used for either. Now a little bit here on the temperature controlled oscillator benefits. Accelerates weak signal acquisition, enabling faster start and reacquisition times. This is relevant for applications with very small antennas or under challenging conditions. If you buy the cheap one with just a crystal-based oscillator, ideal solution for achieving the lowest system costs. Oh well, I've gone cheap. So now I'm looking at the PDF for the Neo-7 series modules. So here's the little module itself, and there's a little table down here, differences between the N and the M. Now this is all about the temperature control crystal again, but you can see here that both of them do GPS and GLONASS, the Russian system. They don't do Galileo, now that's the European system, I don't believe it exists as yet, and they don't do Baidu, which is the Chinese system. We've got voltages here, we've got the interfaces, UART, USB, SPI, and something called DDC, which is I2C compatible. A whole bunch of features here, and the standard professional or automotive grade. Now, specification, a 56-channel Ublox 7 engine. This all starts getting very complicated, but there's some interesting stuff here on acquisition times. Cold starts for GPS are 29 seconds, 30 seconds for the Russian GLONASS system. Aided starts take 5 seconds, and a reacquisition takes just 1 second. And I've got a feeling that the little battery on the board is to hold information, to allow you to do warm starts, if you like, aided starts or reacquisitions, so that you don't have to wait the full 30 seconds for the thing to lock onto the satellites. Now, just one other thing right at the bottom with these interfaces. Just below that, we've got the protocols. There's NMEA. It's all acronyms today. This is the National Marine Electronics Association. So you can see that one of the protocols is very much geared towards marine use, boats in other words. There also is UBX binary. Now I think it was Rob B that said by getting into quadcopter technology, I was opening a real can of worms. Well, it certainly seems like there are quite a few worms in this tin can. So how am I going to get this device to do something right now today? Well, I've got RX and TX, so I could connect those to a USB to serial converter. This is a CP2102. Now what about the voltage of this thing? The datasheet said that it's, what does it say? 1.65 to 3.6 volts. So can I use 5 volts? It looks like there's a 3.3 volt regulator there, possibly. So that means that the module will get the proper voltage, but are RX and TX 5 volt compatible? Well, let's not worry too much about all that stuff. So I've hooked up the USB to serial converter, TX RX, crossed over of course, VCC and ground. Let's just plug it in and see what happens. Right, I've got USB from my PC here. Let's put that like that. Well, the power light is on. And the RX light is flashing about once per second. So does that mean that serial data is coming out of this module here and going back through the USB to serial converter, or serial to USB converter as it is, and going into my PC? Well, let's find out. Now, it's at times like this that I normally resort to using the Arduino IDE. So here's the serial monitor. And look at that. GPS data pouring out of this thing. 1 block of data per second. It looks like utter gibberish, but, well, it's working. Now, let's do this properly. So heading back to the Ublox website, under support, there is a piece of software here called uCenter Windows. It's GNSS evaluation software for Windows. So let's install that and see what that does. And it's a vast and complex application, and there's all sorts of things going on here. There's all these monitors, and I'm getting all these American flags coming up. So I'm wondering whether those are satellites. Now, interestingly, it says up here, no fix. So it's not getting a GPS fix. And that's probably because the module's indoors. But it's quite fascinating just watching this thing. Now up here there are some consoles. This first one is the packet console. So we're watching these NMEA packets coming in. It tells you the size of each packet. There's 1 packet of data coming in, or possibly more than 1 packet of data coming in per second. We've got all sorts of interesting things here. Latitude, longitude. Can't see from this panel what the data actually is. Let's go to the next console. This is the binary console. So once again, I'm getting these 99.99 data packets. So I presume that's invalid GPS data because it can't get a proper fix, but that's all hexadecimal there. What's the next packet? This is a text console. This is the one that I was seeing on the Arduino serial monitor. So again, there are those packets coming in. Now I assume that until we get enough satellites fixed, probably on this panel here, we're not going to get a fix up there. Well, now here's another view. This is the messages view, and it appears that this 99.99 is the horizontal dilution of precision, which is quite fascinating. There is latitude here, there is longitude. There's a northing indicator and an easting indicator. We're not getting any data in from those just yet. So here's the configuration view, and there are a mass of things in here. I've just gone to the very first one, the antenna settings. Now, if I, for example, disable the supply voltage control signal and then try and switch to another one, it says, the message was modified but not sent to the GPS receiver. Do you want to send it now? No, I'm too scared. But I assume that if I make changes and send that to the GPS module, then this stuff gets recorded into the E² prom. In fact, there's stuff here on the E² prom and the SPI flash. But there is just so much stuff here, including, and I mean everything's got its own acronym. What about the ESF GWT, the gyro plus wheel tick? This is just going to take so long to evaluate, but I think that's what I need to do now, is sit and play with this and just try and get my head around all the various settings that this thing has got. Oh, here we are. Look, we've got settings for Galileo, Baidu, GLONASS. Wow. Now, I've opened the workshop window. I've connected a USB extension lead, which I've had to put a clip on because it seems to have some sort of loose connection. Another bit of extension lead. And I do have the GPS module now sitting out on my dustbin out here outside. I was hoping to pick up some satellites, but it doesn't seem to be far enough away from the house. I mean, I'm not going to pick up any satellites up in this direction because they're blocked by the brickwork. Let's just have another look at the screen inside. And although I'm just getting bursts of activity from 3 or 4 GPS satellites here, it's not enough consistent data to get a fix, so no longitude and latitude data, I'm afraid. I think I'm either going to have to get a longer cable, or I might try this. There's a U-Center Android, GNSS solution for Android evaluation app. That might be worth a bit of a play. So some success there, but not helped by the fact that my USB extension lead appears to have a dodgy connection. It's gone very dodgy. Oh, there it is. It's just briefly flickering on. But no, that's not helping at all. But that's got an intermittent connection on there. Bit hopeless, really. So, lots more playing to do with the Ublox Neo-7M module. But then when I've got that working and evaluated and played with the U-Center application, I'm going to connect it up to this, which I showed the other day. And these two data fields are going to be longitude and latitude. And so these items are today's postbag. Cheerio.